Welcome all to Cosmic Eye Astrophotography Workshop, held as part of World Space Week 2021. My name is Fahad. I'm actually working as a scientist engineer at Liquid Propulsion System Center, ISRO. Astrophotography may be considered as a challenging field, but nevertheless, it is quite easy to learn. Even with a mobile phone camera, you're able to take Milky Way photographs or even Orion Nebula or Orion constellation, and even a small peek into the Andromeda galaxy. As part of this lecture, we will look at the possibilities of using different methods to acquire astrophotography images, and also some of the technical terms associated with it. You needn't be scared, because this can be done even without all these technical terminologies. Like I said, even a simple mobile phone camera would also do the trick. In the remaining lectures, an introduction is provided to you for using mobile phone for astrophotography, and also some of the techniques that are used for processing of an image is also explained. First of all, let us try to understand what is astrophotography. Astrophotography is actually a field of photography that deals with the study of astronomical objects through photographs. It may be either for scientific reasons, or it may be even or as an art, a creative art form. It includes the photography of all astronomical objects such as stars, their constellations, the planets, nebulae, galaxies, star clusters, and a lot of other things, including solar eclipse, lunar eclipse, and all kinds of astronomical events as well as objects which occur beyond our control. The key to astrophotography success depends on a lot of factors. The first among those is actually patience. Because there may be some nights where you go out to take some photos, you set up your equipment and you finally go out to take some photos, and finally you realize that the clouds are rolling in. And sometimes you may be trying to take photos for a long time, and finally you realize that the focus was not set properly in your camera. That will be devastating because you have spent a lot of time, yet you have not got the results. So never give up your patience. The second most important is experience. So the photo that you take tomorrow would actually be based on the experience that you have gained today. So with each passing day and with each photographic session, your photographs and the quality of your photographs will actually be increasing. So always make sure to keep on taking more photographs. The third and the most important factor, or the key to success, is actually luck, which is even beyond our control. Because there may be some nights where you would want to capture a certain comet, but then the sky will tell you, no, it is not your time yet. So learn to accept that too. We all know that the earth rotates, and as the earth rotates from west to east, all the stars in the sky appear to move from east to west. And in fact, the rotation axis of the earth is such that it is approximately pointing towards the North Star or the Polaris. So suppose that we are actually taking a camera and pointing it towards the north, and then we are taking a lot of exposures with the maximum possible exposure capacity of the camera. We will see that the stars will slowly start trailing, and in fact, if all the images that you have taken are stacked together, it will start to form a circular pattern about a center, and this center is actually called the Polaris or the North Star. Now let us learn some of the general photography terms. First of all, let us try to understand what exactly is focal length. Focal length is actually the distance between the optical center of the lens system to the plane of projection of the object on the sensor. When we look through the camera, we are actually seeing the tree, which is our subject, and the camera uses a system of lenses for seeing this. And finally, it is getting projected onto a plane where exactly a sensor is being placed. And the distance between this optical center of the system and this sensor, or the plane of projection of the image, is basically what is called as the focal length. Unlike the case of a simple lens, for a camera, its optical center is not a constant, because actually it is employing a series of lenses, and hence the focal length may actually be a variable. In fact, it is possible to have lenses with fixed focal lengths as well as variable focal lengths. What we are seeing here is actually an example of what exactly focal length is. Focal length basically provides a magnification. So if you look at it, a 400 mm lens will actually have a lower magnification than an 800 mm lens. So the more the focal length, the higher the image would be magnified, while the lower one would seem to be very small. The larger one would seem to provide a larger and more magnified image of the subject. The next term that we are going to see is aperture. Aperture is actually a mechanism for the camera to control the amount of light that enters its sensor. It is actually controlled by certain structures which looks like blades, and the blades will effectively control an opening in the middle through which the light entering the camera is actually controlled. So as we are increasing the white area, it means more amount of light can actually enter, and while it is becoming smaller, it means only a less amount of light can actually enter. Aperture also provides another functionality, which is actually for controlling the depth of field of an image. This is in particular not very important for astrophotography point of view, but if you look at it, when the aperture is actually increasing, the depth of field will decrease and only your subject would seem to be focused. The aperture is actually explained in terms of an f ratio or f-stop. It is basically defined as the ratio between the focal length and the aperture diameter. The aperture can actually be considered as an effective circle, and the diameter of that is actually put in the ratio that is mentioned here. Now let us consider an example and see how the f ratio is actually calculated. If the focal length is 70 mm and the aperture diameter is 17.5 mm, then the f ratio is actually equal to 4, or f/4 as it is written. Smaller the f ratio, larger would be the amount of light gathered. That is because smaller the f ratio, larger would be the aperture, and hence a larger amount of light is permitted. Since astrophotography is actually done during night, it is always preferred to have a lower f ratio so that more amount of light can actually enter. The next important terminology is exposure. Basically, any camera has a shutter, and the opening and closing of the shutter will permit maximum or minimum amount of light to enter, and this is what is called as exposure. The exposure is actually always told in terms of seconds. Now let us consider an example of a man running. As the man is running, a very short exposure can only help in achieving a very sharp image. So 1/500 seconds would give a very sharp image of the man running. But as we increase the shutter speed to 1/30 seconds, slow trailing will start to form. And further, when we are increasing to 1/15 seconds, even further trailing of the man's image is formed. And finally 1/2 seconds, a lot of trailing would be seen. So far, we have actually seen the mechanical or physical terms related to a camera. The first one was focal length, secondly there was aperture, and third there was exposure. But ISO is slightly different. It is actually a technique, a processing technique that is followed within the camera, wherein the light entering the sensor is actually amplified as a signal, and it is amplified to increase the brightness of the image. The leftmost image with the lower ISO is actually observed to be darker, while we are moving towards the right, the ISO 2000 is having very bright image formed. So far, we have learned what are the technical terminologies related to a typical camera. Now let us come to an astronomical term, which is the maximum exposure that can be achieved without star trails. Earlier I had mentioned that due to the Earth's rotation, you might see that some of the stars would actually trail when you are taking a long exposure photograph. So for photographing a very sharp image of the star, there is something called a rule of 500, which is actually shown here. So as per this rule, the maximum exposure is basically 500 divided by the focal length into crop factor. Let us try to understand what exactly is crop factor. In general, a DSLR camera can be of two types. Either it can be a full frame camera or it can be a crop sensor camera. If you look at it, a full frame camera has its sensor, which is slightly larger than the crop sensor camera's sensor. Earlier we had learned that focal length is actually the distance between the optical center of the lens system to that of the sensor, the planar position of the sensor. So in fact, the subject that you are focusing on would actually be focused on to the sensor. And here if you look at it, the image in a full frame sensor would be sufficiently large, while in the cropped sensor, it would be cropped out and it would give the impression of a higher focal length, or it would give the impression of a zoomed image. It would be showing an impression. Now let us come back to the earlier slide where we were seeing the rule of 500. So here the 500 divided by focal length into crop factor. This crop factor would be dependent upon the kind of camera and the kind of camera company that is actually there. So this factor can be chosen accordingly for calculating the maximum exposure. Now let us learn a few more technical terms with regards to astrophotography. One of the commonly used term is light frame, and in fact light frames are the most important frames, and these are actually the photographs that we are taking of the object using your camera. These should be taken in large numbers for ensuring that there is sufficient data for processing and stacking. These light frames along with other frames are processed by a technique called stacking, wherein the noise in the images would be reduced. Another lecture would be dealing with how stacking procedure is actually done. So now let us go to the second term in the commonly used terms. So that is actually called a dark frame. These are actually taken with the lens cap on and at the same settings as the light frames, and these are taken in small numbers. This is done actually because the sensor will be having a certain amount of noise which is related to the temperature, and we can actually filter it out from the final image by using such dark frames. Maybe a 10 or 15 numbers would be sufficient when we are taking hundreds in terms for the light frames. Third, we are having flat frames. These are also taken in few numbers, and this is done by using a white sheet over the camera lens with the same ISO and focal length, but automatic shutter speed is used, so that there are some things called vignetting, which I will be showing in the coming slide, and these could be removed from the final image. Also, in due course of time, the camera sensor would be occupied with dust particles and which may be contaminating your image. So the effect of these dust particles will also be averaged out by the help of flat frames. Then the fourth term is intervalometer. It is actually a device that helps in taking a lot of photographs and at specific intervals with the specific settings that we require. So this would limit or minimize the human intervention required in long astrophotography sessions. While we were discussing flat frames, we discussed that vignetting effect can also be removed with the help of flat frames. So this is what is called vignetting. At the four corners there will be dark spots which can actually cause a weird effect to your final image, and to remove that flat frames can be used in addition to dust particle removal. So now we have learned what are light frames, dark frames and flat frames. When all these three are combined together, we actually obtain a stacked image, and that stacked image is further post-processed to obtain the final image. This post-processing is very much necessary to remove any artifacts that are generated during stacking process. Now let us summarize the importance of stacking and calibration. It improves the signal to noise ratio, it makes the image sharper, and it also helps in removing the unwanted artifacts from the images. With these concepts in mind, let us move forward with the lecture. Just like the two sides of a leaf, astrophotography too has two different sides. One is untracked astrophotography and the other is tracked astrophotography. As I mentioned earlier, the Earth rotates, and to compensate that, a tracking equipment is to be used, which leads to tracked astrophotography. This we will discuss in the coming slides. Let us first learn about untracked photography. In this photography, with bare minimum equipment and with bare minimum budget, beautiful photographs of the universe can be taken. Let us learn how. But let me tell you, just like what we discussed earlier, this requires a lot of passion and a lot of dedication to finally get an image that you require and that you can actually appreciate. Let us see what are the different things that are required for proceeding with this photography technique. First of all, you would require a DSLR, but that is not an absolute necessity. You can even use a point and shoot camera. Secondly, you would require a stable platform, and a tripod would suit your task perfectly, but you can always use a cardboard box or a tissue box for supporting your camera. And third, you would require a computer for performing the post-processing of the image that you have taken. And also, fourth, you would require a mobile phone for all the amateurs out there to understand and locate where exactly the subject that you would like to shoot is located in the sky. For that, you can use apps like Google Sky Map or even Sky Tracker. Hoping that you are having all these things ready, let us move on to the fine aspects. First, let us see some of the tips that are to be kept in mind before proceeding with astrophotography. The first one is to shoot RAW. That means to always shoot in the RAW format if your camera permits it, so that you are getting uncompressed form of the data and you can use this simply for the post-processing. Secondly, restrict the ISO levels to low values. Sometimes it may be favorable to go below 1600, and if you're going above that, you'll be getting images with a lot of noise. Third, shoot in large numbers. Always taking large number of photos of the target would help in selecting the finer and excellent ones while stacking, and it also helps in reducing the noise by stacking process if you're having larger numbers. Fourth, always shoot in manual mode, because it is always better to shoot in manual mode to control the various parameters. And finally, you need a dark place with minimal light pollution to finally get the image that you would require. The light pollution in the sky at any place can actually be compared by the help of a terminology called Bottle class. Bottle class 1 offers very dark skies, while we are moving towards the right. It keeps on going to the most polluted sky, and finally Bottle class 9 is the most polluted. This can be kept in mind just for your understanding purpose. Now let us try to see how to focus the lens onto the stars. If you look at the images on the right, the top image would actually show the stars as out of focus, and you can see it is very blurred, while at the bottom we are having stars which are focused and which are like pinpoint. These can be actually adjusted with the help of the focal ring on your camera, and details are actually covered in the lecture 2 of the video. Now let us look at the various targets that can actually be captured. The first is deep space photography, where we are capturing beyond that meets the eye. What you are seeing here is actually a photograph of the Andromeda galaxy. In fact, when I say a photograph, you might think that in a single shot this image was actually formed, but that is very much further from the truth. In fact, this has been taken from a large sequence of photographs of short exposures and have been stacked to obtain what you see right here. And with this, two galaxies also nearby, M110 and M32. And if you look at here, this is actually how it looks like. The first image is basically the single frame that is shown right out of the camera, and after extensive stacking process, finally you are getting the galaxy Andromeda, which is actually the stacked image. Almost 475 light frames have been used along with 20 dark frames, and this has been stacked by using Deep Sky Stacker software for obtaining the final photograph. A separate video on stacking process is also provided as part of the lecture series. So let us move forward and see some other samples. This is actually the Orion Nebula and the Orion Belt, which is actually comprising of 70 light frames of each of 3-second exposures. But let us see like how the single image was actually like straight out of the camera. This is what a single frame looks in the camera, just as you take it in the camera. So you can see that there is no nebula even visible at that location, whereas in the stacked image we could have actually seen the flame nebula. What you see before you is another sample of stacked images, which is comprising of almost 400 images of 3-second exposure f4 and ISO 400. And you can see that several nebula as well as clusters are there, and the small Sagittarius star cloud, Omega Nebula, M23 star cluster, as well as Trifid and Lagoon Nebula are also visible as part of this image, the final stacked image. Now let us see how a single image would look like straight out of the camera. You can see that actually it is very feeble. There are no particular demarcations there. Now let us see what an exposure enhanced image looks like. So you can see that a lot of grains are there, and how much the stacking process has actually improved you'll be able to appreciate by seeing this image. Similarly, in rarest of circumstances, you're also capable of capturing some of the comets. This is actually the trail of comet Iwamoto. This is actually comprising of 70 light frames, and you can actually see the comet's motion with regards to the stars. When the stars are kept stationary, the trailing of the comet can actually be seen. Now let us see the technique towards capturing moon photographs. The most important rule for capturing the moon photograph is actually the rule of 11. If you keep an f ratio of 11 and if your ISO is x, then the shutter speed should be 1/x seconds. So this is actually just a thumb rule, but which works with most of the camera. Always make sure to capture a large amount of photos and then stack them together with software such as AutoStacker, Registacks, etc. Videos for the stacking are actually available in various YouTube channels. However, it is not discussed as part of the present lecture. Let us see how the moon transforms when it is stacked. This is actually a single image taken with the camera and with the f11 rule, where ISO is 800 and the exposure is 1/800 seconds. Now let us see how the stacked image looks like. You can actually see how much improvement is there when almost 80% of the 400 photos have been stacked and contrast has been enhanced so as to see this image. A large improvement is actually seen from the single photograph. It is also possible to capture the glory of the moon even during cloudy nights. Do give it a try. It is not just the moon or even deep sky objects that can actually enthrall you. In fact, it is possible to capture our friendly neighborhood sun by using certain solar filters which are actually placed in front of a camera to prevent any damage to the camera due to the high glare, high intensity light from the sun. In fact, you can also use a welding plate kept in front of a camera lens, which can also provide you with a similar experience. What you're seeing here is actually the annular solar eclipse of 26 December 2019. This is actually photographed with a filter kept in front of the camera and has been processed by using Snapseed on the mobile to show all the phases of the sun together along with the annularity, which is at the center. The leftmost image shows the beginning where the moon actually comes in front of the sun and slowly the transience is shown. Finally the moon shows the annularity and eventually the moon just phases out. A small video is actually shown here with the help of various photographs that were captured during the time of the annular solar eclipse, and you can see how even you can see minor clouds also moving in front of the video. The annularity has been achieved and now the moon is actually trailing away from the face of the sun. Notice how much of sun's intensity has been decreased by the solar filter. Now let us move towards Milky Way photography, where we have to shoot wide and wild. What you see now is actually a single image of the Milky Way galaxy that has been processed. However, this has not been filtered out by using any flat frames. And due to that, you can actually see some dust spots on the camera, which has actually come in the image towards the left side. You can see it where the mouse is actually showing right now. In fact, such kind of artifacts can be removed by the help of flat frames, as I mentioned earlier. And this is the vignetting effect that is actually there in the original photo, which was removed in the post-processing, not with the help of flat frames, but by other techniques. So always shoot with the widest aperture for achieving the minimum star trail. Also experiment with the exposures, and till you find a final star trailing, you can always experiment with the exposure time. And also stack, definitely stack. And also you have to post-process for correcting vignetting, either through the help of flat frames or by using the profile of lenses, which are available in some commercial applications for post-processing purpose. This is actually an untracked processed image, which is a stacked image taken with the help of Nikon D5200 with stock 1855 lens, and it has been taken by Vidhu Srikumar, and as an example it is shown here. For people with access to telescopes, another field is there, which is actually planetary photography, and also those with having high zoom camera such as the Nikon P900 or P1000 can actually capture the planets Jupiter or even Saturn or even Mars. So such kind of people can actually have an attempt at these astronomical objects. Here is actually a video of a planet, the planet Saturn, that has been taken with the help of a camera attached to a telescope's eyepiece, and you can actually see the Saturn moving. From the frames in the video, almost 1200 frames were stacked to form this image of Saturn. Another spin-off from astrophotography field is actually light photography, where you can actually have an artistic approach to astrophotography techniques. What you see now is actually a composite image comprising of a light painting, a background, as well as the moon. Let us see how such kind of light painting techniques can be done. So in fact, all these frames, all these light painting images that you see have been taken on a moon night and a full moon night with a lightsaber like object, which I had bought off from Shangamugam beach for about rupees 80, I guess. And you can actually use these for with the long exposure photography for showing light trails. This can be clubbed with an astronomical object to give a composite approach. These are some other examples that were actually taken by road events, where light photography has been taken to the next level. Along with Milky Way astrophotography, it has been combined. The light has been used to give a flame-like appearance in the photograph on the right side, and such kind of artistic techniques can be used. We have so far seen what is possible by using untracked photography. Now let us explore the field of tracked photography, wherein the Earth's rotation is actually nullified. So here it is actually astrophotography with a slightly larger budget, because these sky tracking equipment do not come in cheap, and in fact, but there are in fact some alternatives towards taking budget astrophotography in a tracked manner. This also I will just brief in the coming slides. What you see before you is actually a sky tracker. When we are looking through one side, we can actually align the axis of the tracker with the North Star or the Polaris. And if you are shooting from Trivandrum, this angle, the angle theta that is shown there, is roughly around 8.5 degree. And this depends on the latitude of the place that which you are in. And accordingly, the star tracker can be adjusted and the camera can be mounted on top of the star tracker. And an arc motion will be followed by the tracker to track the stars. Unlike the star trail photograph that you saw in the beginning of this lecture, with that star tracker you will be having crisp and clean stars if properly aligned to the Polaris. If you are actually pointing the camera at the Polaris and if you are looking at it, you would see that actually as the stars are rotating in counterclockwise fashion, because of the Earth's rotation from west to east, the sky will actually be seen to be rotating from east to west, and along with that the star tracker also will rotate in very fine steps, and that will prevent any trailing. Let us see some examples of stacked and tracked photography. What you see before you is the Trifid and the Lagoon nebulae. These are actually nebulae within the Milky Way galaxy, and this is actually a photograph comprising of several stacked images. Whatever you see, the colors are actually the hydrogen alpha emissions, or various other emissions are also there, but hydrogen alpha is predominantly seen with the pinkish hue. Nebulae are actually star forming regions where new stars arise, and these are actually gas clouds. Now let us see some other images also. This is actually the Andromeda galaxy, commonly called as the twin galaxy of Milky Way, our galaxy. Earlier we had seen untracked image, and now we have seen the tracked image. You can see how much of an improvement over untracked image a tracked image can actually provide. And in fact, a clean image is also seen. The noise is very less, and stars are pretty sharp. And also the neighboring M110 galaxy as well as M32 galaxies can also be seen. With the help of a star tracker, an attempt has also been done to see the Earth's rotation. If you look at here, the sky is actually kept a constant while the Earth's rotation is actually captured. So you can actually see what is the kind of rotation we are actually seeing when we are looking at the sky. This is reversed and then shown in this time-lapse video. What you see before you is actually a time-lapse of the comet Neowise that came in 2020, which was actually captured by myself and my friend from Trivandrum. So these are actually various photographs that are put together to show the relative motion between the comets and the stars. In fact, the tail of the comet is actually visible. The tail comprises of dust as well as various other gases, which trails away from the comet as it moves. That can also be seen. As I mentioned earlier, star tracking equipments are slightly more expensive, but here is actually a less expensive Bando tracker, which is actually an affordable option made by Chandan Saxena. It is actually made from household items with very few electronics equipment also made. Now let us see some of the astrophotography software which are actually used for various processing purposes. These are actually some of the software that are used. For stacking a starry sky, we can actually use the software Equator, Deep Sky Stacker, Cyril, and there are a few others also. And for stacking the moon, there are some other categories such as AutoStacker as well as Registacks, which are quite different from the deep sky stacking photographs, deep sky stacking software which are mentioned above. Apart from that, there are also techniques for ensuring taking the photos and stacking them or aligning them one over the other in order to form something called star trails, wherein you'll be capturing the trailing of the stars by using some software, and these are called star trail photography, and the software can be star trails or star stacks. Similarly, there are other software for capturing and processing lunar eclipse as well as solar eclipse time lapses. IMPPG is one such software. There are also other software for manual stacking, Photoshop, which is actually a paid software, and also GIMP, which is actually an open source, wherein manually you can align the images one over the other and perform the stacking process. And also for capturing panorama photos or for creating panorama from numerous photographs, you can actually use Microsoft's image composite editor, which is once again a software which is free, but I think it has been recently phased out, but some older versions may be available presently. There are few more software such as StarNet++, which permits you to actually play with the photograph and remove all the stars and maybe only have the nebulae in the picture. And there are also planetary imaging post-processing, which is actually a software called PIP that can be used along with AutoStacker for stacking planets such as Jupiter, Saturn, etc. These are overall the software that are typically used for astrophotography purpose. Now let us see some of the astrophotography targets. What all can be shot as part of the contest, and as well as even for as a hobby, what all images can you actually take? Let us see those.